In this video, I'm going to give you a formal proof of the fact that the supremum of the open interval from 0 to 1 is equal to 1. I already said it that this was the case, but now we're going to give a proof following the definition. So let's get started. So as I said, we want to show that the supremum of the open interval 0, 1 is equal to 1. So we need to prove two things. First, we need to show that 1 is an upper bound, and then we have to show that 1 is the smallest of all the upper bounds. Okay, so first let's take a look at the definition of the open interval 0, 1. The open interval 0, 1 is just the set of all real numbers x such that x is strictly between 0 and 1. So we know that x is less than 1, and therefore x is less than or equal to 1 for all x in the interval 0, 1. But that means that 1 is indeed an upper bound of the interval 0, 1. So now what we need to show is that 1 is the smallest upper bound. And to do that, we're going to follow this idea. If I pick any number less than 1, I'm going to show that it cannot be an upper bound. Okay, so as I said, we already know that 1 is an upper bound. I'm going to pick a number, m less than 1, and I'm going to conclude that m is not an upper bound. So how do we do this? Well, as I said, we want to show that m is not an upper bound, and it's a good idea to write this down to guide the reader, to let the reader know that that's what we're thinking, because the reader cannot read your mind. It can only read what you write. Okay, perfect. So if m is less than or equal to 0, then m in particular is less than 0.5, and 0.5 is in the interval 0, 1, so that means that m is not an upper bound, because m is less than an element in the set. Okay, very good. So now what happens if m is between 0 and 1? So I'm drawing it here at some point in the line in between 0 and 1, there I have my point m. Well, you see, I can pick the midpoint between m and 1. So this little x, blue x that I'm here, pick something in between, but the easier choice is the midpoint, because I can write it as n plus 1 over 2. That is the midpoint between m and 1. Okay, so then we have this number is bigger than 0, is less than 1, so x is in the interval, open interval 0, 1. And x is bigger than m by the way we constructed. So this shows that m is not an upper bound. But that's exactly what we wanted to do. Isn't that great? So perfect. That means that 1 is indeed the supremum of the open interval 0, 1. And that completes the proof.